Year 9s, we're going to start talking about a little bit more about parabolas and about how we can transform them and what different things in an equation mean. So, the first, actually I think it's back to its default things. Let's draw in blue this time. Okay, so let's talk about what it might look like if we have different numbers in front of the x. So let's take, for example, y equals x squared. So just that normal graph looks like this. Whoa, that's not straight at all. Let's try that again. All right, it would be exactly in the center. It's still not quite right, but you get the point. So y equals x squared looks just like this. So whatever y is, x is, okay? So the same sort of thing. It's exactly in the middle, all right? Well, don't worry about it. It looks like that. Okay, so what we're going to do is we're going to talk about what putting a number in front of it might mean. So if we have different things that look like this, what would that do to the shape of the graph? Okay, we'll do one here and one here. So if we have a dilation factor of less than 1, which is this one down here, because this is, sorry, I didn't even say that. The number before x is called the dilation factor, okay? Dilation factor. So whatever number is in front of the x squared is the dilation factor. That just means whether the graph is going to be a bit wider or a bit skinnier, okay? That's what that means. So what we're going to do is figure out what it might do. So if the dilation factor is less than 1, the parabola is wider, okay? So it would look a bit wider than this one, than the first one we did up here. 2x is going to look a bit skinnier. So if the dilation factor is more than 1, so, you know, most numbers, it's going to be thinner, like that, okay? So it pushes the graph inwards or outwards, depending on this dilation factor number. So either 2 or a half will do this to it, okay? So it won't really change where it is, where the turning point is, but it will change whether it's sort of wide or thin. So that's a really important thing to remember. If you have something like y equals negative x squared, what that means is you flip it upside down. The negative dilation factor, so really that's a dilation factor of -1, isn't it? Because you don't say 1x, you just say x because, you know, it's implied that there's only one of them if you don't say it. So if there's any sort of negative, all it means is you flip it upside down. If we made this one over here negative half x, it would be the same thing upside down. Same here. If y equals negative 2x squared, exactly the same thing. It would be skinnier, but it would be upside down because there's a negative, okay? So if it's a positive number, it's a smiley face. If it's a negative number, it's a frowny face. Just think of it like negative is sad, you know, you're being negative, or if you're being positive, you're being happy. So that's how to tell whether it's going to be upside down or not. And the dilation factor helps you understand whether the graph is wider or thinner. Now let's talk a little bit about translation sideways. And I've lost my, there we go, let's turn the page. Okay, let's talk a little bit about a translation. So whether the graph moves up or down, okay? If we have y equals x squared, let's do that again. So just so we remember what it looks like, it's just a normal graph like that. This is your y and this is your x, okay? What if we had, oh, here we go, it wants me to update something. Let's update later. Thank you very much. So if we have y equals x squared plus 2, this is a translation of 2. And because it's a positive number, we're going to go up 2. So let's say we went 1, 2. What we're going to do is we say our graph now looks like this. Okay? We've gone up 2 places. So we haven't moved sideways at all, we've just moved up 2 places. That's what this second number tells us. What if we had y equals x squared minus 4? Okay, well, same thing. Let's go 1, 2, 3, 4. All right, so we've got the same graph, but we're going to move it down 4 places because that's what this translation part is telling us, okay? So if it looks like this, we just look at the last number and say, all right, where do we want to put our turning point? Remember, turning point is fairly self-evident. It just means the point where the graph turns. Okay, so We can also go left or right. So this is how we know whether we go up or down. But what we're going to do, actually, I'll put that in the next video. So for now, that is how you go up or down. And the previous page, we talked about whether we know about dilation factors. So make it wider or thinner, or go up or down.